find f of -6, f of -1, and f of 8 for the piecewise function. Whenever you have a piecewise defined function, students' first reaction often is to plug this number x into all three of these functions and get three different answers. But it wouldn't be a function if you did that, because to be a function, for every input value, you can only have one output value. So you can't have three different values as output for one input. So you can only pick one of them. And the way that you choose is through these ranges of values right here. Let me draw a number line. So I have one region of numbers where x is less than -1. So I'll put in -1 here, and x is less than -1 going this direction. Okay. And then I have another region where x is between -1 and 5. So I have this other number 5 up here, which is another boundary point. Now I'm including -1, but it's still less than 5. So all the values in between there I'm going to shade orange. And lastly, where x is greater than or equal to 5. So from here on. So notice each of those sets, there was no overlap. So that's how we determine that there's going to be only one answer. We pick the function based off of which range of numbers this value exists in. So -6. So -6 would be over here on this blue region somewhere. And this is not to scale because I didn't have enough points for that, but that's okay. It is less than -1, which means I use this function right here. So -7 times -6 plus 7 is going to be 42 plus 7, which is 49. Okay, now let's go on to part B. So this wants me to evaluate f of -1. So -1 is actually this boundary right here. And remember, you can only have one output value per input. So you have to choose which one includes the -1. So this range right here includes -1. So I use this function. So this would be -1 squared plus 8, which is 1 plus 8, or 9. Okay, and lastly, f of 8. So 8 is going to be somewhere over here. It's on the range where it's bigger than 5. So we're on this last range here, so I use this function. So 8 minus 6 will give me 2 as an answer.